Hello, Assalamu alaikum, learners wherever you are. Today we are learning steel pipe titration. The questions still remains the same. There is no much difference. So we have this question today. You are provided with it's missing. You are provided with 2 molar of hydrochloric acid, 0.4 sodium hydroxide solution, solid H, which is 1.0 gram of metal carbonate. Now, we don't know the value of X. We know it's valence 1, group 1 element, but we don't know much about it. Okay, procedure: you measure 50 cm of the acid, hydrochloric acid, then you place in a 250 ml polymetric flask. Then you add all solid J, not solid J here, solid H, not solid J. You add all solid H, and then you stir until effervescence stops. Then you add still water up to the mark. Then you label as a solution R. You have prepared a new solution. Fill the burette with sodium hydroxide solution. Then you pipette 25 cm cube of solution R that you have prepared, and you place in a clean conical flask. Then you add 2 drops of methyl orange. Then you do the titration. So when you do the titration, this is what you see. Final burette reading 20, 20, 20. Initial burette reading 0.0, 0.0. Final volume used, you subtract the final minus the initial. So we have 0 here. 0 is non-significant, it's not bringing any change. You'll get 20, 20, 20, 20, 20. Then let us go to the calculation part. The first question is here. Calculate the average volume of sodium hydroxide used. To calculate the average volume of sodium, sorry, not this one. I'm in a wrong page, So let me go to my page. Yes, this is where I am, So this is our question, not the one the questions I was saying was not our question. So here where we are. Now calculate the average volume of sodium hydroxide used. To calculate the average volume of sodium hydroxide used, this is what you do. Average volume is equal to 20 plus 20 plus 20 divided by 3. Where is it? If I go back, this is 20, 20, 20. You add all these 20, then you divide by 3. 20 plus 20 plus 20 is 60, divided by 3, 20 centimeter cubic of sodium hydroxide used. This is the volume of sodium hydroxide used. Then Roman 2. Roman 2 is asking the number of moles of sodium hydroxide used. To calculate the number of moles of sodium hydroxide used, you have the volume used, which is 20 centimeter cube of sodium hydroxide. Then you will also get the molarity of the base. You will get the molarity of the base. So the base, you have 0.4 molar of sodium hydroxide solution. And again, you have here the volume used. Then this is what you said, 0.4 molar is equal to 1000. 20 centimeter cubic, how much will it be equal to? You cross multiply. Then when you multiply 20 times 0.4, then you divide 1000. Then this is what you get, 0.008 moles of sodium hydroxide. Then we have question Roman 3. Question Roman 3 is asking the number of moles of hydrochloric acid used to react the base. So since you have the number of moles of the base that you have reacted with the acid, then to get the number of moles of the acid, then you write an equation. Equation is sodium hydroxide plus hydrochloric acid, sodium chloride plus water. Then you balance the equation. Sodium 1 here, sodium 1 here. Okay, hydrogen 1 here plus 1. Hydrogen we have 2. Here 1, 2 hydrogen. And here we have 2 hydrogen, balance. Oxygen 1, oxygen here also 1, balance. Then chlorine 1, chlorine 1. So the mole ratio is 1 to 1. Since the mole ratio is 1, the mole ratio is 1 to 1, then the number of moles is the same. So the number of moles of the acid and that of the base will be the same because one cannot change any value. So therefore the number of moles of the acid remains the same with that of the base, 0.008 moles used. So that is the answer of question 3. We have question 4. The number of moles of hydrochloric acid in 250 centimeter cubic of solution. So that's what we are going to calculate, the total number of moles of 250 centimeter cubic of solution of the acid. When we prepared solution R, we are going to get the total number of moles, which is the excess number of moles of the acid that remain from the carbonate. So how do you calculate that? First of all, this number of moles of the acid that we have here is the number of moles of the acid in this volume. In this volume. Where is the procedure? In this volume. The procedure, we have 25 centimeter cubic of solution R. So this 25 centimeter cube of solution R contains this number of moles, which is 0.08 moles. Then what about 250? So that's what we do in the next question. 0.008 moles of the acid contains 25 centimeter cubic. So what about 250? Then you cross multiply this 25 to this 250, you multiply this value, then 25 it will go down. Then when you cancel 25 and you multiply the upper part, then you divide 25, this is what you get. So this is the total number of moles of the excess hydrochloric acid in the new solution that you have prepared, solution R. So the next question, which is question 5, is the number of moles of the original hydrochloric acid in 50 centimeter cubic. So the original hydrochloric acid in 50 centimeter cubic, we have the original hydrochloric acid, the molarity as 2 molar of hydrochloric acid. Then the total volume of the original hydrochloric acid is 50, as they indicated in the question. So how do you get the total number of moles of the acid before it reacts the base and before it reacts the carbonate? Then we say 2 molar, which is the molarity, is equal to 1000. What about 50 centimeter cubic? X, we don't know. You multiply 50 times 2 molar, then you divide 100. Then you get 0.1 moles of HCl. This is the number of moles of HCl before it reacts either carbonate and a base. We can also call the total number of moles of HCl before it reacts anything. This is the total number of moles of HCl. So the next question, which is question 6, is asking, let us see it. The next question, question 6. Question 6 is asking the number of moles of hydrochloric acid that reacted the carbonate. The number of moles of HCl reacted the carbonate. Question 6. How do you get? You subtract the total minus the excess. Yes, you subtract the total, which is the total acid, the total number of moles of the acid, which is 0.1, minus the excess, which is this one. Subtract it. Then you get 0.02 moles of hydrochloric acid reacted the carbonate. That's the answer of Roman 6. We have Roman 7. The number of moles of the carbonate used. The number of moles of the carbonate used. Since you have the number of moles of the acid reacted the carbonate, how do you get the number of moles of the carbonate used? You use the equation, you react the acid and the carbonate, you balance the equation, you use the mole ratio. So let us see it. You use that. So X carbonate plus hydrochloric acid is equal to X chloride plus carbon dioxide plus water. Then you balance it. X2 here, X you put it here, 2. Now hydrogen 2 here, then you also put 2 here, hydrogen. Chlorine 2, chlorine 2. Yes, chlorine here 2. Then carbon 1, carbon 1. Okay, oxygen 3 here, oxygen 1 plus 2, which is 3. Now the equation is balanced. The mole ratio here is 1 to 2. So the 2 mole ratio of the acid is equal to the number of moles of the acid, which is 0.02 moles. Where did you get this 0.02 moles? Let's go back. It is this one. This is the number of moles of the acid reacted the carbonate. So it's equal to its mole ratio. It's equal to its mole ratio, which is 2. 2 is equal to this moles. Then what about 1 mole ratio from the carbonate? Then 1 times this one. Then 1 times this one. Then divide by 2. Then you get 0.01 moles of the carbonate reacted the hydrochloric acid. That's how you do it in this question. So we have the next question. The next question, which is from Roman 8, is asking the relative atomic mass of the carbonate. How do you calculate the relative atomic mass of the carbonate? The relative atomic mass of the carbonate always is equal to this number of moles that we have obtained here. This number of moles of the carbonate that we have obtained here is equal to the total mass of the carbonate. Total mass of the carbonate. The total mass of the carbonate, where are they? Let us look at the total mass of the carbonate. According to the start of the question, the mass of the carbonate with solid H was what? 1.06. Then this is what you do. This number of moles, which is 0.01, is equal to the mass, which is 1.06. 0.01 is equal to the mass, which is 1.06 gram. What about 1 mole? Where am I bringing from this 1 mole? You have learned that if we have sodium hydroxide, and you want to calculate the RFM of sodium hydroxide, sodium 23, oxygen 16, hydrogen 1, you have 40 gram per liter. Sorry. When you are calculating now the RFM, 23 plus 16 plus 1. 23 is from the sodium, oxygen 16. 23 from sodium, oxygen 16, hydrogen 1. When you add all of them, you will get 40. When you get 40, this 40 is the RFM, or molar mass. So the molar mass, or the RFM relative formula mass, or the molar mass, or the RFM, whatever you call, the unit that it has is always gram per mole. Meaning that any compound, when you sum up its molar mass, it's always equal to 1 mole. So whenever you're calculating RFM, it's always equal to 1 mole. So 0.01 mole is equal to this number of moles. This is the mass it's equal to. This is the number of moles of the carbonate used, and this is the mass of the carbonate used. So they are equal. 1 mole, which represents the RFM, is equal to X. We don't know. 1 times this, then divide by this one. You get 106. So when you get that, that's how you solve the RFM. Then our next question is the value of X. To calculate the value of X, where C, carbon is 12 and oxygen is 16 in the bracket. To calculate the value of X, then you have the RFM. You take the compound X2, X carbonate is equal to the total mass of the RFM. Then here X, since the value, the letter that you are looking, this is the value that we are looking. The value that you are looking, it has X, is it? So always that X, if it has a number, you make that number the coefficient. If it doesn't have any X, you put it direct plus. So since now it has 2, you make that 2 coefficient. 2X plus carbon 12 plus oxygen 16 times 3, because there are 3 oxygen here, then it's equal to 106, which is the RFM. 2X plus 12, then 16 times 3, 48, is equal to 106. So 2X, you take again, continue taking 2X, plus, then this you add 12 plus 48, is equal to 60, it's equal to 60, then it's equal to 106, you take this value. Then now here you have positive, this one is positive, this sign is positive, 60 is positive. When you transfer to the other side, you collect like times, it's minus. So 2X is equal to 106 minus 60. Then 2X therefore is equal to 46. You divide both sides by 2. Then you'll get X is equal to 23. So since X carbonate was written like this, and 23 is the RFM of sodium, then the compound was sodium carbonate. I think you're understanding. Thank you.